Yeah, no, thanks, Sina. So as Sina mentioned, I think at the start of this meeting, so we're going to have we're going to have a series of panel discussions. It's not so much of a formal panel discussion. We'll have a fairly open conversation amongst the various pilot participants. So we're going to start with more of the scenario part of the pilot, which focused on flooding, but I think we can expand it into other types of disasters as well, since a lot of what came out of the pilot is widely applicable across different types of emergencies. Um, so, and then we'll get into more focused conversations on DGGS itself. So some of the commentary on that, and then on specifics related to the AI elements of it. So I think what we're interested in getting out of all of these pilots is to have more of an understanding of the participants' experiences within the work itself that was undertaken as part of this specific project, and then getting into discussion of yeah. So what we're hoping to do as part of this panel session is to get perspectives from the participants on their work within the context of the project, and then have suggestions and recommendations for next steps for future work. So we'll start with the flooding side, and what I would suggest is for participants who want to answer the questions, I guess raise your hand and we'll direct you to, or we'll go to you. And then as for everyone else, if you do have a question, please post it in the chat, and I'm sure we could have you ask the question verbally as well if you're interested. So first question for flood risk. So what I would ask is, based on your experiences in the pilot, can you comment on the value of DGGS for flooding, like flood risk, other flood applications? Are there particular applications in the context of flood risk that you think that DGS is better suited for, or are there approaches, or are there specific applications where other approaches may be more preferred? Oh, yep, someone's raised their hand, so please go ahead.
Yes, thank you. It's Lucas from Hartis. And my name is in Greek. Apologies for that. I joined from my institutional account. I think something really important was how we can easily and fast query with spatiotemporal data. And while we were testing, for example, the ERA5 datasets with multiple and many different parameters like snow melt, precipitation, etc., it was quite easy and fast to aggregate data temporally speaking, to query different resolutions, resolution 5, 8, 9, or maybe start an analysis from resolution 5, and in areas of high flood risk, let's say, then to have a second or a third analysis at the resolution 8, 9, or 10. That was really, let's say, an added value of the DGGS usage. And of course, we should always remember how we can play, let's say, in quotes, with the different DGGS systems. I mean, with some quite easy to use parameterization, we may change the systems from H3 to real heat peaks, or IZEA 3H, or IZEA 3H, etc. So I think this was something really interesting and important. Thank you.
Great, thank you. Yes, anyone else? I posted the question I asked in the chat, so it's if you could read it if that's helpful. Yeah, and again, if there are other, I would encourage everyone, if you do have other your own questions related to flood risk, if you're an attendee or a participant, please go ahead and ask, so we can have a conversation.
Yeah, Dean Hintz here from SAFE. Just to comment quickly on question 1. Yeah, I think DGGS is very valuable for flood risk, particularly when you're looking at building a flood risk index and then applying it to a range of different domains for different types of impacts. So I think there's a lot of good potential there. I think some of the challenges might come in to when you're looking at higher resolution data, or maybe evaluating a whole time series. I think some of the tooling for that, and also, yeah, integrating more high resolution, because given the different types of grids, getting everything aligned, I think that we're still sort of working on some of the tooling on that. I would be curious for if, you know, what the comments might be from some of the client participants on dealing with higher resolution. So I think when you're dealing more with flood risk index, you have sort of like a probability surface of flood risk. I think it's very useful for that. If you're trying to actually predict, you know, doing hydraulic modeling and then predict where the flood's going to go, it might be a bit harder using DGGS for that, but that's just my general impression.
Thanks, Dean. Any other comments on this question, or maybe related to? Yes, sorry. Go ahead, Nathan. Yeah, you're on mute, Nathan. Sorry.
Thank you. Sorry about that. So just prior to starting this project, we were working with our main sponsor on this work, Army Corps of Engineers, and they had a number. They had expressed a data management challenge to us, which is, as they've modeled multiple inundation scenarios for, let's say, a particular body of water, each inundation scenario would carry with it a different geometry, depending on the level. And they said just managing all that was incredibly difficult. And so we actually presented to them DGGS and said, well, this seems like this would be a much would be a viable alternative because of the dynamic nature of the API itself, so that you could actually query the API. If you were to take all these inundation scenarios and quantize them into zones, then that you'd have a central point for getting information on these different inundation levels. And they were really excited about that. So in that scenario, it seems to really simplify the data management piece, if that makes sense.
No, I think so. Yeah, I think there are a lot of good in your work and others in this pilot as well, demonstrating the value of DGGS for simplified data integration and having things being consistently presented at a location. Yes, go ahead again.
I'm trying to lower my hand, and I'm done.
It's me again, Lucas. Just to add to what Nathan mentioned, it was quite impressive how we managed to reduce the number of queries on the servers. It's, let's say, more technical, but having the opportunity to query at the resolution 3 or 4, let's say, but at the same time using this, parent zone parameterization, you may ask for multiple data sets at resolution 8, 9, or 10 without hitting the server, let's say, or overloading the server. That was really, really helpful. We tested that for the past 2 months. It helped us a lot to reduce, the running times for the models, because it's a vast amount of data, topographical ones, hydrological ones, environmental ones, socio-economical ones. So with just a few queries, even in different servers, we could have a big volume of data without overloading the servers.
Okay, no, excellent. Thanks.
Thank you.
Yeah, go ahead, Peter.
Can you hear me?
Yep.
Okay, great. Yeah, sorry, I've been sitting on the sidelines watching, and I have a question for the people who set up DGGS servers. It seems that DGGS is well suited when the data set is constrained, like it would be in an emergency scenario where you're only concerned about an area. But it sounds like you sort of have to pre-compute the cells. And how would that scale out to something like, I have the Sentinel archive and I want to build a DGGS grid on top of it? Does that actually work? Or I'm not sure if I completely get how that would be set up as a DGGS server. Does that question make sense?
Yeah, I think Jerome was first to respond.
Hi, Peter. Yeah, so about the question regarding Sentinel-2, so we've sort of implemented that, And also, I think also related to Dean's comments about whether DGGS is suitable at a high scale. So the idea is if your backing store somehow has a concept of multi-resolution, and that might be cogs with overviews, which you have some of that to some extent with the Sentinel-2 data, except depending on the source product, it might not go all the way to one-by-one overviews. And also the fact that it's kind of pre-split into multiple granules kind of adds some challenges. But the idea is if you have the data at multiple resolution already, when you try to map this to DGGS, you can actually do it at runtime because you don't have to go to the full data. So if you already have some kind of overviews, then you can resample and use basically the next closest resolution so that you don't really lose precision when you do the resampling. So
Okay,
that's
so
kind of
you don't
how
have
it
to,
scales.
right? So you don't really have to pre-compute these things and store them somewhere, right? Is what I'm getting at.
I mean, what you need to do multi-resolution is you need some kind of pre-computed overview somehow, right?
Yes.
It could
Okay.
be it doesn't need to be in exactly the same DGGRS, although that is what will give you the fastest response. But if you
Right.
have something in any kind of DGGRS-like thing, and that includes cogs and geo packages that kind of have these overviews or 2D tile matrix sets or a WMTS service, anything like this with multiple resolution, then you can leverage that and use the next best resolution so that you don't really lose anything when you resample because you're resampling from more finer data going to the coarser one, so you don't use too much, and then you can achieve scale and performance as long as you have that. But it's a little bit difficult with the Sentinel-2 in particular because of how it's kind of already pre-split into different granules. And you need because there's so many of these small granules and you don't really have like big overviews because the biggest pieces are quite small, so that's a bit challenging, but it's kind of doable.
Okay, thanks. I think that answered my question, Jerome. Thank you.
Thank you.
If I could figure out how to get my hand down, I would, but I can't.
It's okay. I think I can lower people's hands, so it's fine.
Right.
I saw
Thank
Johan had his hand up briefly, so I don't know, Johan, if you wanted to comment as well on that. But
yes, but actually, Jerome said nearly the same thing, so I won't add anything else.
Okay, no problem. All right, maybe we can move on to a different question. So one of the other questions I had. Oh, sorry. There's yeah, there is a question in the chat that's posted. Yeah, so this is more about the integration of what the participants' thoughts are on the integration of AI with DGGS to support flood risk needs. So what worked well and what needs to be improved. So maybe we can move the discussion to focus a little bit more on the AI side in the context of flood risk. So does anyone have any thoughts on their perspectives with the use of AI in the pilot and combining it with DGGS? Yeah, go ahead, Dean.
Again, I'll defer to the folks that worked on the clients who can kind of perhaps provide more precise examples. But my general experience with the way we were serving up DGGS and working with folks like Terraframe and also Hardis is that I think DGGS did a very good job of providing geospatial context for AI. So in the absence of DGGS, you would have to, if you just had location names, you might do geocoding and reverse geocoding if you're running from an LLM. So you have to sort of ask the question, well, what would we do if we don't use DGGS? And so some of these geocoding methods are not going to be very precise. So basically, DGGS just gives the AI a language for asking spatial temporal questions about, well, where's the flood risk in this region or in this time frame. So I think that that was demonstrated very clearly in the pilot. And then I guess was the other part of the question. Sort of like how bidirectional it is. I suppose there I feel like we're only scratching the surface is how do you do the AI orchestration? So you know, yeah, you can make DGS, you can maybe wrap it up in MCP and make it available to AI agents. But then how do you do sort of cascading? So ask for flood risk, then ask for different domain information about the impact of that flood on populations, on infrastructure. So how you kind of do that whole cascading logic with AI, that's, at least for me, it's a bit fuzzier. And I think some of the questions around that are what sort of metadata do we publish alongside the DGGS services so that they are more easily discoverable by AI. So I'm answering your question with a question. Anyway, that's my 2 cents.
Yeah, no, thanks. I think that's great to consider for future work. Stelios.
Yeah. When we initially tested the client that we prepared, asking questions about getting data and analyze them, the system seems to bringing H3 zones easily and providing answers, meaning that it could understand what is a DGGS system, but the identifiers were not at the same place that we're asking about, meaning that we had hallucinations. I'm saying that the LLM understood what is DGGS and it made up information. So we put a lot of effort in guardrail the LLM in order to get the authoritative data. To go closer to the question is that we found it that it was helpful, easy for us in order to have data from different sources in one cell and make calculations on a specific cell. That was really easy. And yeah, this can be a road to further complex analysis, I think, if you have all the necessary data to present to a model and have them in a space that you can have a low resolution and a higher resolution at the same time doing granular analysis. I think this is very helpful, and that opens a road for further achievements on geospatial reasoning. I think this is my impression, at least.
Yeah, no, absolutely. No, thanks, Stelios. I think Michael is next.
Yeah, thank you. Michael from Geo Insight here. I'm trying to answer that question, what the benefits for AI and DGS are, and if they're mutually. I see 2 ways in which AI can interact with DGGS. The one is obviously, and that was most explored in this pilot, through an LLM. What I see where the real benefits are is when you use and write an AI model that interacts with these zones and takes these zones as tokens. It happens exactly the same when you train a model on text. The text has to be tokenized. It has to become ones and zeros in a sense. And a DGGS gives you exactly that. It was actually a request from the Geo AI domain working group. They were looking for ways to sort of tokenize space. They were actually saying exactly these words, spatial tokenization. And DGGS delivers you that. The data may be sparse, and you may only have a signal in a few of your zones, but that is also information. You know that the zones in between don't have something. And if you train an AI model, I did this way back in a research paper, it actually is a very digestible format you have all your zones with all the values and parameters that you collected from your data sets. And then you label some of these zones with the phenomenon that you want to classify. And it is a super effective and efficient way to do this. And it goes a bit to that point of also, do you need to pre-transform your data? And I would say, yes, if you want to run an AI model in that idea that I just laid out, then I would say you don't do this on-the-fly transformation. But that's a bit of a different angle to DGGS than what was explored in this pilot. I hope that helps as an answer. Thank you.
No, thank you. Yeah, I think it definitely does. And Justin was next.
Yeah, just quickly, I think from our point of view, kind of what worked well and what needs to be improved from the AI standpoint. Like, I think one of the big benefits that the AI, at least LLMs, gave us was more of an accessibility thing. I don't think a lot of people are like super knowledgeable about DGGS and the new OGC API. So having the ability to make natural language questions to anything and like sort of just encapsulate that and get somewhat of meaningful responses from it was a big benefit. I mean, AI does that for a lot of domains, but it's certainly a benefit for this. I think, that's kind of easing the sort of input into DGGS. I think what needs to be improved and what people have talked about is kind of getting output from DGGS and kind of doing further down analytics from it with AI. Yeah, I mean, I think a lot of other clients, not just Terraframe, we ended up putting like orchestration layers about to handle the response from DGGS as opposed to just like directly giving output back to some sort of LLM model to like let it summarize data. That didn't work very well. And so I think that is kind of the next area of improvement.
Okay. No, thanks, Justin. Yeah, I'm sorry. Did you want to say something else?
Nope.
Okay.
That's all I got.
All right. No, thank you. Yeah, I think your comments are spot on. Yeah, because certainly for the emergency management community, I think like the generative AI piece is going to be really helpful for better using geospatial data in general, but particular DGGS. Yeah, so maybe that is a next future area of work is to figure out how those interactions better happen, and to improve the analysis component that you were talking about. Yeah, lastly, I think Jerome.
Yeah, so thanks. So like, as I put in the chat, I think something that we didn't really explore in this pilot, and maybe somewhat radically different, but not so different to what everyone is currently already doing in the geospatial, maybe more with regular tiles, which are rectilinear. The idea of the subzones, which is kind of the core of things with the DGGS API and the zone data responses, is really intended for getting like millions of zone values back. So it's really for like a high throughput analysis scenario. So which is kind of why the other endpoint was proposed, the slash zones for the kind of thing that we did in the pilot, where we basically just asked the server for a few values where maybe the server already summarized things. But it would be interesting to explore kind of this zone data retrieval with the subzones. And doing using an LLM in a similar way that the image LLM handle things, where basically when the LLM looks at the data, it's looking at a particular parent zone specifically, and then it's kind of used as this attention mechanism, which is kind of the big boom behind the big thing behind the AI boom, where it basically relates all of the values inside the parent zone to make sense of what you see inside this one big data packet. And then you can further combine this with the other parent zones around, but kind of making sense of what is inside this big parent zone with all of the millions or thousands of millions of values in here, and then further aggregate this with the zones around. So I think that would be the very interesting approach, which is more similar with how like image analysis is done, but applied to any kind of DGGRS, including like the hexagonal, like the IVIA 7H and all of these. And that's kind of what one of the things that the subzone concept of the data retrieval would make possible. So I think that would be very interesting to explore in the future activity.
No, absolutely. Yeah, I think for emergency management, that's particularly interesting, where you're likely interested in impacts in a particular area or set of areas. So that might be a very powerful capability for the community. So maybe to move on, so one of the components of this pilot that we were interested in testing was with DGGS was to see if it could act as a common operating picture, which in emergency management is this idea of having a kind of a single pane of glass, if you will, that allows you to access all the information that you need to support an emergency management operation. So I'd be curious to have the perspectives from the participants on your thoughts on how DGGS functioned in this within this idea of a common operating picture. So did it work well? What needs to improve, that kind of thing. Lucio.
Yes, here I am. I think I feel a little bit on the focus now. Yes, I was going to answer before, but you are right. I think the best place where DGGS can work with AI and give benefit to each other from the application of each other is exactly in the COP area. Common operating picture means transferring from one user to another, from a server to another, or to a client, information, a scenario that include different level of information with different quality, with different things inside, so with the security and all the rest. So at the real end, there you can take benefit of DGGS because you can really precisely identify the volume, in this case of the flooding of the area to be defined, or the area, or just the area to be under investigation or during the emergency, and filter the other way around the artificial intelligence LLM results on the document, all the information around the proper event. Imagine you are doing a flooding simulation, so we have answer from the algorithm. For what we have seen, artificial intelligence results are seen like a collateral data, but in any case, you can weight this data. You can stream the information in a certain way together with the geospatial precision of the DGGS, so you are able to give to the user a sort of well-packaged common operating picture with information that a human can always evaluate, but with certain confidence about the results they are there. Not only this helps also in querying better all the algorithm and all the services you are passing to another, so the common operating picture can be an orchestrator that define possibility to access or not certain services to be retrieved to the final user or the people that is receiving this COP. My humble point of view.
No, thank you, Lucio. Yeah, any other thoughts from anyone else on the common operating picture concept? Okay. If not, or wait, sorry, go ahead, Dean.
Yeah, I think to Lucio's comment, so I think there is a lot of potential using this kind of the approach that Lucio outlined in for like an OWS context kind of description and all of the sort of accessibility and provenance and trust information. I think one of the challenges is applying this specifically to a specific domain, such as disaster impact or flood risk. I think maybe what's missing here, while what we've and Lucio knows the COP stuff much better than me, but my general impression is that DGGS provides the geospatial context. We can have a specific zone and then, you know, look at subzones and hand that information around. There's lots of, from sort of an OWS context perspective, there's the concept of metadata around, okay, which data sets are, you know, having links to data sets, etc., of you know, what the location of those data sets are and you know, permissions around them. But I think what might be missing is I don't know, maybe a metadata description specific to disasters. So if an AI is searching for flood risk data for looking at, let's say, the potential for flooding in spring, you know, next month, you know, let's say in May this year, what data sets should it query? And then once it has those and starts asking questions via DGGS or via other APIs, how do you accumulate risk across different domains? So let's say you want cumulative risk, not just due to flood, but you know, let's say flood impacts transportation impacts economics. So you're kind of going across very different domains. So I think the common operating picture needs to be, yeah, I think more work needs to be done to define what COP means for a specific context like disasters, and you know, which, like specifically, you know, different risk indexes that where, you know, if you're querying one server and get a risk index back, you can apply that risk index, you know, a cumulative weighted risk index between multiple queries, and then somehow sum that risk, have a sense of accumulated risk. And then you also have this idea even of certainty. So the results that we're producing, what's the level of certainty of that result? What's the horizontal resolution, temporal resolution, and probabilistic certainty? So these are some of the things that I think from a COP perspective, we, at least I don't have a solid understanding of how we can sort of accumulate information between different data sources, APIs, in order to come up with cumulative effects.
Okay. Oh, thanks, Dean. Yeah, I think Lucio wants to respond.
Yes, thank you, Dean. Exactly, that was one of the items in the second part of the slide I presented yesterday. One slide I added, but it was exactly dealing with the weight of the result, trying to define how much this information is good, but also is dealing with what I wrote there about the dynamic creation of ontologies. And if you use properly DGGS to define small areas or areas in a certain way that are good for the specific phenomenon that you are dealing, emergency or whatever, then you are able to create this set of information, very specific, and extract automatically out of this data dictionary, vocabulary, and then ontologies that you can directly display on the interface. At this moment, the user is more comfortable about this, the information he receives, because she receives, because it's not spare. This information is quite well concept, specific for the item. You know, Dean, I was doing this with your software well before starting this adventure alone. So that's something exactly what people want, and it's true. The information of the artificial intelligence depends strongly on the data they use. That's why I'm suggesting small local language model to use specific information. This requires some other parameter, but it requires a lot of discussion, and the definition of the revision of the OWS context, that is 2007, I think is mandatory in this sense inside OGC, because it's something that is due for all the technologies and all the new things coming, standards coming up in these days.
Okay, thank you, Lucio. And Lucas.
Yeah, I will be super quick just to add to what Dean and Lucio mentioned, and I posted here on chat. As it seems, we may have a great opportunity for, let's say, on-the-fly uncertainty analysis. And that's a great added value, to be quite honest. The you may have an analysis or querying for data at a resolution 5, but having the uncertainty levels at a resolution level of 6, 7, 8, and 9. And let's say you may have integrated results and outcomes, whether it's related to flood risk or other natural disasters.
Okay, excellent. No,
Thanks.
thanks, Lucas. Yeah, thanks everyone. So I think we'll thanks everyone for your comments on this particular discussion. So I think we'll move on to the next one, which I think is on DGGS more specifically. So I'll pass the floor back to Sina.